Hey guys, welcome to our channel. So we've been decoding the agreed upon section of Bible changes. Um, and we've gotten our letters to go through all the categories, and we've gotten our numbers to go through finance or stock market. We got them to go through genetics and medical and chemical, all forwards and backwards. And we've gone now forwards through atomic numbers, looking for nothing but atomic numbers. And now we're backwards. Now, I did my best not to repeat sequences because they're there twice. I mean, there's some repeating number sequences here. Um, we may have hit one that we hit yesterday because I missed writing a couple of them down yesterday. So a couple of them seemed very familiar for some reason. Maybe we'd gone through them before in a previous search or something. But um, I also wanted to note that in our chemical search we got a lot of steel. And in our forwards search for atomic numbers, we got a lot of metals. We've also got a couple of gases. And I found that to be interesting, and I don't know that I mentioned it in the video, in the previous video, but if anyone remembers in the chemical video, we did get a chemical and biological masks, and then you got some gases in there. So I thought those connected as well. But a lot of metal and a lot of steel, right? So, um, if you, these are your numbers, and whoop, 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 whoop. There, I think that's a good shot. And they go all the way across. And then they come back and start over and come all the way across. They're corresponded to their letters, and I will provide the link at which we correctly extracted the letters and converted them to numbers. Um, so, getting into this, we've already come forwards, and now we're coming back, and we're starting with number 32. And number 32 ends up being germanium. Now, something told me we'd gone through that before, but it's a silvery white semi-metal. It is brittle. It was discovered in 1886. 1886. Atomic number 32. It's a semiconductor. Uh, used as a transistor in thousands of electronical applications. Today, however, other semiconductors have replaced it. It's now a major suitable for use of wide-angle camera lenses and objective lenses for microscopes. That's a major use. So, are transparent to infrared radiation, so they are used in infrared spectroscopes. All right, but germanium, and it is a metal, semi-metal, excuse me. All right, but if you move on from that, guys, you got number 26, 26, and that ends up being iron. And these are all going to be on the periodic table except one interesting one that is not. But we'll get to that. But iron, and iron's obviously a metal. Shiny gray metal that rusts in damp air. All right, I think we all know what iron is. And I think it does have a biological role. I could go down here and look. It's an essential element for all forms of life and is non-toxic. The average human contains about 4 grams of iron. So that's a lot of it's in the blood, it says. So moving on, guys, I think we all know what iron is. Oh, and if I missed it, it was discovered, approximately 3500 BC. All right, that's a long time ago, right? So they say. So, if you move on from that, you have number 15. And I didn't write number 15 down. Is it because we had it before? No, I have it. I may just have things a little out of order. So you have iron. Oh, because I did 62, guys. 62 we had not yesterday, several days ago. Whenever I did part one of this, we had samarium. So we already covered samarium, and I'd forgot to write it down up top. I think it was one that I did not write down. So I wrote it down now. But yeah, 62 is samarium, and I'm pretty sure I provided that link yesterday. So if you move on from that, you have number 15, which ends up being phosphorus. And it was discovered in 1669. Two main forms of phosphorus are white phosphorus and red phosphorus. White phosphorus is a poisonous, waxy solid, and contact with skin can cause severe burns. It glows in the dark and is spontaneously flammable when exposed to air. Red phosphorus is an amorphous, non-toxic solid. So, and I'll spare the uses. I think we can all figure out. They're used for matchboxes, the side of matchboxes stuff. Well, yeah, stuff to match stuff. So if you move on from that, guys, you got atomic number 92. I'm trying to get through all this quickly. You got 92 is uranium, and it was discovered in 1789. If that, I'll spare a lot of details, but it's a radioactive silvery metal. A very important element because it provides us with nuclear fuel used to generate electricity in nuclear power stations. All right. So uranium, I think we've all pretty much heard of uranium before, but here it is. It's in these changes for whatever reason. So if you move on from that, you have number 9, because I didn't do 9 by itself yesterday. And number 9 ends up being a Mandela effect, actually, fluorine. Fluorine. And I think that fluorine is a Mandela effect. Fluoride, spelled UO now. That's an effect for a lot of people. I seem to remember it spelled the other way myself. But it's a very pale yellow-green, dangerously reactive gas. It is most reactive of all elements and quickly attacks all metals. Steel wool bursts into flames when exposed to fluorine. There was no commercial production of fluorine until the Second World War, when the development of the atom bomb and other nuclear energy projects made it necessary to produce large quantities. Before this, fluorine salts, known as fluorides, were for a long time used in welding and frosting glass. I'm trying to see, guys. Fluoride, I know they use it. I don't see. It's an insulating gas for high-power electricity transformers, solvents, and high-temperature plastics such as Teflon. Fluoride is an essential ion for animals, strengthening teeth and bones. Okay, so yeah, that's a weird one, but there it is, guys. And I'm sorry that I spent so much time on it, but that was an interesting thing. I did not know all that about fluorine. But if you move on from that, guys, you have number 58, and that ends up being cerium, C-E-R-I-U-M, discovered in 1803. It's a gray metal. It is little used because it tarnishes easily, reacts with water, and burns when heated. So, metal alloy, just under 50. It's a major component of misc metal. MISCH. Yeah. So I'm not going to spend a lot of time on it, guys. There isn't a whole lot to say about it. It's a metal, though, and that's the interesting part. So if you move on from that, you have number 33. And number 33, atomic number 33, ends up being arsenic. Yes, arsenic is a semi-metal. In its metallic form, it is bright, silvery gray, and brittle. Arsenic is a well-known poison. Arsenic compounds are sometimes used as rat poisons and insecticides, but their use is strictly controlled. Oh, surprisingly, arsenic can also have medicinal applications. In Victorian times, Dr. Fowler's potassium arsenate dissolved in water was a popular cure-all tonic that was even used by Charles Dickens. Today, organoarsenic compounds are added to poultry feed to prevent disease and improve weight gain. Oh. So, okay, biological role. Some scientists think that arsenic may be an essential element in our diet in very, very low doses. Oh, I don't think I like that. Why would it? No, 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 no. In small doses, it is toxic as a suspected carcinogen. Once inside the body, it bonds to atoms in the hair, so analyzing hair samples can show whether someone has been exposed to arsenic. Some foods, such as prawns, contain a surprising amount of arsenic in a less harmful organic form. Okay. Well, so there's arsenic for you. Discovery date approximately 1250. So it's a semi-metal. All right. My apologies, guys. We're trying to get through this as quickly as possible. If you move on from that, you get number 3. And atomic number 3 is lithium. All right. And its discovery date was 1817. Excuse me. All right. Lithium is a soft silvery metal. It has the lowest density of all metals. It reacts vigorously with water. All right. So you got lithium. It's toxic except in very small doses. They use it in rechargeable batteries for mobile phones, laptops, digital cameras, electric vehicles. Lithium is also used in some non-rechargeable batteries for things like heart pacemakers, toys, and clocks. And it is made into alloys with aluminum and magnesium, improving their strength, making them lighter. So you got lithium there. And if you move on from that, you got atomic number 14, which ends up being silicon. And it was discovered in 1824. And the element, when ultra pure, is a solid with a gray metallic sheen. A solid with a gray metallic sheen. One of the most useful elements to mankind. Most is used to make alloys, including aluminum silicon and ferrosilicon, iron silicon, which it is ferrosilicon. Transformer plates, engine blocks, cylinder heaters, machine tools, and deoxidized steel. Oh, so you're dealing with steel. It's essential to plant life, but its use in animal cells is uncertain. All right. So that's silicon. And if you move on from that, you end up with atomic number 49. And atomic number 49 is indium. And it was discovered in 1863. And it's a soft silvery metal that is stable in air and water. And it is used to make indium tin oxide, ITO, which is an important part of touch screens, flat screen TVs, and solar panels. All right. Indium has no known biological role. It is toxic if more than a few milligrams are consumed and can affect the development of an embryo or fetus. So, and they spelled fetus wrong? Foetus? Must have been a typo. Fetus, though. That's what I'm sure it is. So that's indium. And if you move on from that, you have, I went ahead and did atomic number 4, and you get beryllium. This was one that we may have repeated. It was discovered in 1797. It is used, it is a silvery white metal. It is relatively soft and has a low density. It's used in alloys with copper or nickel to make gyroscopes, springs, electrical contacts, spot welding, electrodes, so on and so forth. Um, so, yeah, and that's interesting because we had copper in our last search, and we're about to have nickel in this one. So that is interesting. So beryllium, number 4. If you move on from that, I went ahead and got 49. And 49 ended up being what? Indium. Did I have that twice? Beryllium. No. Somehow I do have indium twice. I'm not sure how that works. Or I just clicked on the wrong thing. Silicon, indium. Oh, I just clicked on the wrong thing, guys. My apologies. There's a lot of information here and a lot of windows. So if you move on from that, I took number 2 by itself. That's what we did. Number 2. And 2 ended up being helium, discovered in 1895. It's a colorless, odorless gas that is totally unreactive. It's used as a cooling medium for the Large Hadron Collider and the superconducting magnets, scanners, and spectrometers. It is non-toxic, but no known biological role. All right, now we're back on course. But if you move on from that, you end up with, and that was a gas, guys. If you move on from that, you get number 24, and that ends up being chromium, and it was discovered in 1798. If I've missed some of these discovery dates, I apologize. 1798, this one though, chromium, a hard silvery metal with a blue tinge. Chromium is used to harden steel to manufacture stainless steel, named as it won't rust, and to produce several alloys. And I'm not reading everything, guys. I'm trying to get through it relatively quickly. Chromium is an essential trace element in humans because it helps us use glucose. However, it is poisonous in excess. We take in about 1 milligram a day. Foods such as brewer's yeast, wheat germ, and kidney are rich in chromium. Kidney. All right. Sure. Kidney. I don't eat kidneys, but maybe some people do. I don't know what they mean there. But anyway, you got chromium. And then I went ahead and took 121 to see if because these repeated guys, I don't know that I told you when they repeated, but they were repeating, and we got back to 12 and 21 again, which we've had both. And so I took 1, 2, 1, and you end up getting unbunium. And it is actually not on the periodic table of elements because from what I read about it, it is a theoretical element, which I find to be interesting in and of itself. Appearance unknown because it's theoretical. This is not the site that told me it was theoretical, but this tells you about the element. It even says standard state, presumably a solid. But yeah, it's it is a theoretical element. So that was interesting. So, but we moved on from that, guys. It's theoretical. Easily a calculation point would be a theoretical element. So if you move on from that, you have number 91. And number 91 is protactinium. Protactinium. It was discovered in 1913. Excuse me, guys. 1 second. Apologize for that, guys. These get to being long, and seems more and more I have to pause that. But anyway, guys, protactinium, discovered in 1913. If I missed that, it's a silvery radioactive metal. Protactinium is little used outside of research, so they say. Protactinium has no known biological role. It is toxic due to its radioactivity. Small amounts of protactinium are found naturally in uranium ores. All right, so that's protactinium. And if you move on from that, you have number 28, and atomic number 28 ends up being nickel. And that was discovered in 1751. Surprising amount of nickel. Apparently, there's a large amount of nickel in baked beans. It's a silvery metal that resists corrosion even at high temperatures. And it's used to plate other metals to protect them from corrosion. Alloys. The biological role of nickel is uncertain. It can affect the growth of plants and has been shown to be essential to some species. Some can cause cancer if the dust is inhaled. It's nickel. And some people are allergic to contact with the metal. Nickel cannot be avoided completely. We take in nickel compounds with our diet. It is an essential element for some beans, such as the navy bean that is used for baked beans. All right, so that's interesting. Nickel. But if you move on from that, you get atomic number 93. 93. Oh, and I also missed number 52, tellurium, but we already covered that yesterday. I just forgot to write it down, so I wrote it down here. But you got number 93, which ends up being neptunium. And it was discovered in 1940. It's a radioactive metal, little used outside of research, so they say. It's an isotope has been used in neutron detectors, excuse me. No known biological role. It is toxic due to its radioactivity. All right. But if you move on from that, you got potassium at number 19. That's atomic number 19. That's potassium. We may have had that yesterday, but it was discovered in 1807. It's a soft silvery metal that tarnishes in air within minutes. So we're getting a lot of metals again. The greatest demand for potassium components is in fertilizers. It's essential to life. Potassium ions are found in all cells. So you got potassium. Then you got number 35. And atomic number 35 is bromine. It was discovered in 1826. It is a deep red, oily liquid with a sharp smell. It is toxic. It's used in areas of research, agricultural chemicals, dyestuffs, insecticides, pharmaceuticals. Maybe it was maybe they had another typo and it was insecticides instead of insecticides. Now this is insecticides, so maybe that's what it was that I was trying to read. It's present in small amounts as bromide, excuse me, in all living things. However, it has no known biological role in humans. Not sure. But if you move on from that, guys, you got number 67, number 67, and number 67 is holmium. It was discovered in 1878. It's a bright silvery metal. It can absorb neutrons, so the nuclear reactors to keep a chain reaction under control. So it's yeah. All right. It's non-toxic though. There ain't a whole lot to say about it. Holmium, Holmium. But if you move on from that, you have number 16, and number 16 is sulfur. And its discovery date was prehistoric. And there are several allotropes of sulfur. The most common appears as yellow crystals or powder. So I think we all pretty much know what sulfur is. But if you move on from that, you got number 65, and atomic number 65 is terbium, and it was discovered in 1843. It's a soft silvery metal. It is used to dope calcium fluoride. We had fluorine, right? But there's several other things here. No known biological role and low toxicity, though. But if you move on from that, you got plutonium at number 94, and that was actually something I said I was going to look up from yesterday going forward, because I looked all around it but didn't do 94. So, yeah, that's plutonium, discovered in 1940. It's a radioactive silvery metal. Plutonium was used in several of the first atomic bombs and is still used in nuclear weapons. All right. So, and then you had a repeat of 59, which was from yesterday, praseodymium. So I tried to avoid the repeats, guys, and if I got a couple, I apologize for that. But that gets you through going backwards, and now forwards and backwards with atomic numbers. A lot of metals, some toxic gases, some gas mask stuff, and a lot of steel stuff in the chemical search. So it kind of interesting how it went through and tied in there. And I don't know about that theoretical element. I wouldn't have had to run that because we already ran all that, and I just decided to run 1, 2, 1 to see if we got anything, and it ended up being theoretical. Well, we'd already got 12 and we'd already got 21. We could have moved right past that. But we didn't, and I'm kind of glad we didn't, because it's kind of interesting that you end up with a theoretical element in there. So that's going to be it for atomic numbers. Next, we'll do technology. And I'm not sure what number sequences we'll run, but we'll figure it out. So for now, guys, thanks for all your thumbs up, thumbs down. Thanks for all your comments, leads, feedback, and subscriptions. Keep wanting to think I'm forgetting something, but I think I covered it all. Again, some of those number sequences repeated themselves, and I mostly skipped them because we'd already ran all the sequences we could run with them forwards, and then they just repeated back. So that happened quite a few times coming back. So, but that doesn't mean it didn't go through. That means they went through again and again and again, and the same dang thing for whatever reason. So I find that to be actually interesting because you got a pattern here going, and when I'm looking at it, you got a pattern, and then a little bit, then it repeats the pattern. So you got like a repeating number pattern in here that you wouldn't catch with the letters. So I find that to be interesting. So anyway, guys, for now, thanks for watching. We'll hit technology next. And for now, you guys have a great rest of your day.